Welcome to Guruji Physics modules. Today we are discussing about Fresnel biprism, that is interference produced by Fresnel biprism experiment. Before I start the video, click the subscribe button, then enjoy the video. Fresnel biprism. It's an experiment to show the phenomena of interference. We will discuss a complete experiment in a easy to understand language. So we have divided the topic into subsections such as definition, function, principle, construction, working. So let's start the topic with the very first heading, that is definition. Now, when I am saying Fresnel biprism, I would say it's an experiment to show the phenomena of interference. Clear? What's the function or the purpose of this experiment? Function is to produce two coherent sources of light. Its purpose is to produce two coherent sources of light. Clear? Now, on which principle this experiment works? This experiment works on the principle of division of wavefront. Division of wavefront means primary wavefront divided into two secondary wavefronts. These two secondary wavefronts would act as two coherent sources of light. Because these two sources have been produced from a single source, that's why these are coherent. Clear? So the principle for the production of two coherent sources of light by Fresnel biprism is division of wavefront. Done? Now we will discuss the construction of the apparatus. For the construction, let's observe this figure. This figure demonstrates the Fresnel biprism experiment. If one by one I discuss, here we are observing S. S means source of light. Here I have considered S to be a monochromatic source of light. Clear? Second setup that I am observing here is this triangle. This triangle is Fresnel biprism. Clear? Then finally at the end, XY is the screen on which we are getting the interference pattern. Clear? Now, experimental setup consists of optical bench. Optical bench is a stand provided with a scale. This optical bench is also provided with three uprights. Uprights in the sense stands. Very first stand is for adjustable slit. Second is for biprism. Third is for micrometer eyepiece. These three stands can be rotated about their own planes by means of a screw. Clear? So we will discuss each and every stand one by one. Very first stand is having slit. This slit can be illuminated by a source of monochromatic light, and that source we have taken as a sodium lamp. Clear? Point number 2. Second upright contains Fresnel biprism. This is a very important component. When I am using the word biprism, bi sounds for two. But if I focus on the figure, this figure is a triangle. This triangle represents the biprism. So where is the word bi? As it appears as a single prism. Clear? In actual practice, it's a single prism. It's made up of a single glass plate whose major angle is 179 degree and the two minor angles are 30 minutes each. But it appears, I'm using the word appears, as if it's made up of two right angle prisms. which are joined base to base. But in actual practice, it is made up of single glass plate. Clear? Last upright is screen. It's made up of a eyepiece provided with a micrometer. So this was a complete experimental setup for performing Fresnel biprism experiment. Done? Now for discussing the working of Fresnel biprism, I have to first focus on the diagram. So let's focus on the diagram and start with the very first component, that is S, source of monochromatic light. When I am saying light is incident on the upper refracting edge, but near the obtuse angle, near the corner of the obtuse angle. Suppose the beam is incident as SU. When the beam enters in the biprism, it would get refracted. Suppose the path of refracted ray is UF. The beam is incident on the screen XY at the point F. Clear? Similarly, consider another ray that is incident on the lower refracting edge of the biprism. Suppose I am considering beam SV. This V point is near the corner of the obtuse angle. This beam, when enters into the biprism, it would get refracted, and the path of refracted ray is along VE. So the beam is incident on the screen XY at the point E. That means EF is the pattern on the screen that I am getting due to the beams that are incident on the point SU and SV. Clear? Now I consider the beam SP. P is the point along the outer edge of the biprism, means near the minor angle. When the beam is incident at the point P, when it enters into the biprism, it would get refracted, and the path of the refracted ray is along PA. Clear? So on the screen, I have the beam incident at the point A. Similarly, I may consider another beam SQ. Again, Q is the point near the minor angle, outer edge. When beam is refracted, the path of the refracted ray is QB. Is it clear? Now on the screen, I have the beam incident at the point A and at the point B. So AB is the portion on the screen. Now on the screen, I have two wavefronts, EF first and AB second. So what would be the intersection area of these two wavefronts? EF, complete region from E to F, and then AB, region from A to B. So what is the where is the region where the superposition of these two wavefronts take place? Region is AB. Clear? It's clearly visible from the diagram. AB is the area or the portion of superposition. When I am saying superposition, directly means interference. Is it clear? So AB is the portion where interference pattern is observed. Now I can name this superposition as interference only if it has been produced from coherent sources. Now come on this particular point. We are getting interference pattern on the screen. It's clear. But how this experiment is used to produce two coherent sources of light? Focus here. Now I come on the screen side, and when I observe the pattern AF, if I extrapolate the path AP in the backward direction, if I extrapolate the path FU in the backward direction, in the backward direction I have shown dotted lines. These beams appears to come from the point S1. Beam AP and beam FU appears to come from S1. Clear? Similarly, beam EV and BQ in the backward direction. These two beams appear to come from the point S2. Thus, on the screen, the pattern appears to come from two virtual sources S1 and S2. Because these two sources have been produced from a single source, so they would act as coherent sources. What was the aim of this experiment? To produce two coherent sources of light. Because these two sources are coherent, when they produce a superposition pattern on the screen, that pattern would be named as interference pattern. Is it clear? The steps of working are written over here. Point 1 is light from monochromatic source illuminates the slit S. Point number 2, S illuminates different refracting edges of the biprism. Now, waves in the pattern EB appears to come from S2. Waves in the pattern AF appears to come from S1. Here, two virtual images S1 and S2 of the slit X act as coherent sources and forms interference pattern on the screen only in the portion AB. Clear? So this was the working of Fresnel biprism experiment. Done? Next is discussion of interference pattern. If I discuss the interference pattern, interference fringes are alternate bright and dark bands. So what would be the expression for the path difference? Same as we have calculated in Young's double slit experiment, path difference comes out to be xd upon capital D. Here x is the distance of first maxima from the central maxima. Small d is the separation between two virtual sources S1 and S2. Capital D is the distance of slit from the screen. Clear? Now, first is the condition of central maxima. For finding out the condition of central maxima, equate the path difference equal to 0. So, xd upon capital D is equal to 0. Clear? Next is condition of maxima. What's the condition of maxima? Path difference equal to integral multiple of lambda. So, equation would be xd upon capital D is equal to n lambda. Here n varies from 0, 1, 2, 3 onwards. Is it clear? Last is condition of minima. For minima, path difference is odd multiple of lambda by 2. So equation would be xd upon capital D equals to 2n minus 1 lambda by 2. Here n varies from 1, 2, 3 onwards. Is it clear? So this was the complete Fresnel biprism experiment, definition, principle, construction, working. Done? Thanks. In our next video, we will consider the applications of Fresnel biprism experiment. So for more updates of the upcoming videos, click the subscribe button and keep enjoying our videos. Thank you. Thank you very much.